Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
It is hardly possible to find a car owner who would not dream explicitly or implicitly that his four-wheeled friend was much more powerful. When we buy a car, we are primarily interested in its complex characteristics, from color and exterior to economy, functionality, and maintainability. Powertrain capacity is rarely at the top of the list. But after a certain amount of time, we begin to realize that it would be nice if our car was a little sharper, horses by 10-30-50. 100, depending on the appetite and driving style. If we turn to statistical data, the average car owned by an average Russian has a 1.6-liter engine with 120 horsepower. But a formula car with the same engine volume can produce 5 times as much. It is not surprising that the race for horsepower spilled out of the laboratories of car manufacturers into numerous tuning studios, specializing in the modification of standard power units in order to significantly improve their dynamometric characteristics. It should be noted at once that such a service is rarely feasible for an ordinary service station. A modern car has a huge number of units and assemblies, the functioning of which is connected with each other in one way or another. Therefore, thoughtless intervention in the design does not lead to anything good. Forcing engines as a way to change their performance characteristics just involves complex measures, taking into account the mutual influence of all systems. And this consideration is based on a deep understanding of the physical processes occurring both in the engine itself and in the units serving it, from the cooling system to the exhaust pipe. To be more specific, there are only 2 factors that determine a car's performance parameters: engine power and torque. Therefore, the lion's share of efforts when boosting engines is aimed at increasing these characteristics. Which motors can be boosted? Many owners of budget cars are absolutely sure that their car cannot be forced, giving a lot of inexplicable reasons. This is complete nonsense. It is possible to force any, with very rare exceptions, power unit, gasoline, or running on diesel fuel. If you do not use turbine installation, you can raise the power bar using iron modifications and by values of about 10 to 20%. On the one hand, such an increase seems insignificant, but on the other hand, to increase the power from 100 to 120 horsepower can be considered a real success. Taking into account the fact that if desired, this indicator can be raised up again and again. Installation of turbocharging is the most expensive but cardinal way of solving the problem, which allows you to increase the power output by 40% or more. But what does a boosted engine mean in terms of engine life? Will it decrease or increase? There is no unambiguous answer to this question. It all depends on what exactly has been modified, as well as on the individual characteristics of the power plant operation by a particular car owner. As you know, many modern manufacturers of passenger cars design them in such a way as to be able to produce tuning modifications in the future. This is what the specialists of numerous tuning studios, both well-known and working on a local scale, use. And if you compare a factory car and a tuned one, the resource of the latter can be 50 to 100% more. How can it be explained? It is very simple. The process of mass assembly, and even on unified chassis, and this is a trend of the last decade, does not imply individual tuning of each car. The whole technological process takes place within the strict limits of existing tolerances and standards. In other words, if there are opportunities to improve the engine design and its servicing systems, they are present here in a very long-term form. That is, at least at the next restyling. Tuning specialists are not constrained by such limitations, and if they find any solution that allows to increase the power of the power unit, they have no problem implementing it. Of course, taking into account the accompanying changes in other components. At the same time, they are able to take into account balancing, weight distribution, and other variables that characterize the overall balance of the car to the nearest millimeter and gram. Of course, if everything were so simple, there would be no quiet cars left on our roads. But the majority of those who want to force the engine of their car face the fact that such an improvement of the engine is very expensive. because it is necessary to make changes in the design of other units, transmission, suspension, brakes, etc. This is especially true in case of installation of turbocharger, as an option, mechanical compressor. Therefore, the vast majority of motorists prefer to improve the engine without using such a cardinal means as a turbine. The main methods of forcing the motor. In English, one of the meanings of the word force is to strengthen something. In our case, we are talking about an automobile engine. As a rule, its forcing and the concept of tuning, tune means tuning, are synonyms. Thus, under the forcing of the power unit should be understood as a whole set of measures aimed at refining the factory internal combustion engine. Such works are just the sphere of interest of tuning companies of various scales, highly specialized and wide profile. And although the ultimate goal is the same, to increase the power of the engine, there are almost 24 ways to force the engine. And this number is only increasing. Of course, their contribution to the common cause is not equal. Some methods imply the growth of power characteristics by values of less than 1%, which can hardly be called tangible, and the accuracy of determining these notorious percentages can always be doubted. We will try to consider only those of them, which have proved their efficiency by hundreds and thousands of examples of real operation, and not only by instrumental and laboratory measurements and studies. And one more point, it is not our task to consider the option of installing a turbocharger. This is a topic that deserves a separate consideration, if only because it requires more radical changes in the design of both the powertrain itself and other systems of the car. Mechanical boosting. Every car owner, thinking about acceptable ways to increase the power of the motor, should ask questions, the answers to which can be decisive in making the final decision. The main question is, what is the purpose of such tuning and how necessary it is? Other equally important questions arise from it. Will the motor characteristics be improved sufficiently so that in a year there will be no ideas about a new improvement? And will the cost of boosting be justified from the financial point of view? And only if all the answers to the partly philosophical and partly rational questions are positive, one can think about concrete implementation. There are two main directions of boosting, so-called chip tuning and mechanical methods. The first option involves changes in the algorithm of the work of the holy of holies of a modern car, the onboard computer. It is now responsible for coordinating the work of all systems, guided by the readings of numerous sensors and actuators. In this case, no independent change in the control program is out of the question. The task of reprogramming ECU requires a thorough knowledge of the algorithms of the controller, and it is closed information, access to which costs a lot of money. And, of course, the availability of appropriate knowledge. The main advantage of chip tuning can be called non-interference in the design of the powertrain. The increase in power occurs by changing the settings of the program, changing the code itself and or adding new controllers. Read also, what you need to know about the width of tires. On the contrary, mechanical boosting involves making changes to the standard units of the factory motor and often the installation of new, modified, or additional ones that make the engine work more productive. If you have a good command of locksmith tools, the technical side of the task may be quite easy for you. But when forcing the possession of such skills is clearly not enough, because any changes in the design of the car, whether it is the engine, suspension, or even tuning the interior, requires careful calculation of the need to make changes in other units that affect the behavior of the vehicle on the road at different modes and loads. Tuning ateliers specializing in forcing motors have their own tested developments aimed at increasing the speed of the power unit. Such work requires careful calculation of the increased load on the piston group. In particular, the desired effect is achieved by replacing the chainers with parts made of titanium alloys. They are much stronger and lighter, although titanium itself cannot be called an ideal material because of its high plasticity. This is important where the working dimensions are measured to within microns. The load requirements for the lower connecting rod head are increased, which in turn sets the task of strengthening bolts and studs. And such parts usually cost an order of magnitude more than the original ones. Strengthening the piston group invariably affects the performance of other engine components. For example, the demands placed on the timing chain. If the upper speed limit has increased, the elasticity of the valve springs must be changed accordingly. They must be able to cope with the task of closing the plates at increased speeds, as they were not originally designed for this. This is achieved by reducing the weight of the valves and/or by reducing their heat dissipation, which from the point of view of physical processes is a non-trivial task, solved by using new materials and their combinations, ceramic metal, titanium, high-strength steel grades. Increasing the RPM requires efforts to prevent resonance phenomena in the intake/exhaust tracts of the power unit. This is realized by making changes in the design of the camshaft, intake manifold, and its exhaust counterpart, using a more accurate multi-throttle intake when each cylinder is equipped with its own damper. Most likely, it will be necessary to optimize the shape of the channels, not only in the cylinder head, but also in some parts of the intake tract. This is achieved by using very specific algorithms, blowing the engine in order to identify points with increased resistance to airflow. Note that tuning modification of the intake tract in complexity is not inferior to making changes in the piston group. Moreover, if light boosting is performed, the intake takes on the bulk of resources, including financial. Increasing displacement in purely theoretical terms, the most successful way to improve the engine output is to increase its total working volume. Technically, it can be realized in different ways, by increasing the number of cylinders, increasing their diameter, changing the piston stroke. Of course, adding cylinders is a task that can be solved only by the automaker, so it can be immediately discarded. That means that real changes can be achieved by adjusting only the last two parameters. But even here, not everything is simple. It is possible to change the cylinder diameter and exactly in the direction of increase, but it is necessary to subject the cylinder block to the appropriate treatment. This operation is called boring. It is often used when performing engine overhaul. The only thing left to do is to select new pistons with increased diameter and then apply micro roughnesses to their surface to improve their adhesion properties with the oil film. It is easiest to make such changes to power units that have aluminum blocks and wet insert liners. In this case, it is easy to find a new set with a larger diameter, as there is a wide range of them in the retail network. A more difficult task is to increase the stroke of the pistons, because for this you will have to make changes to the crankshaft. More specifically, you have to increase the radius of the crank. Fortunately, the automotive industry also comes to the rescue here. There are a huge number of crankshafts on sale, including for use on tuned engines. Forcing an engine by increasing its displacement requires the use of so-called long-stroke or, on the contrary, short-stroke versions, depending on the change in cylinder diameter or piston stroke. In some cases, both parameters are adjusted, but then the selection of the required components becomes more complicated due to the reduced number of suitable variants. It should not be forgotten that a change in engine displacement affects both the power parameter, measured in horsepower, and the RPM at which the power peak is reached, as well as the torque. These are interrelated characteristics, and this dependence is quite definite. An increase in power and torque corresponds to a decrease in crankshaft speed. Increasing compression ratio. The power of an internal combustion engine is essentially the force that the piston exerts on the crankshaft to make it rotate. One way to increase it is to change the compression ratio in the cylinder. By increasing the compression ratio in the combustion chamber, you can get more output from the engine for the same volume. Theoretically, this means that the increase in power will not affect the efficiency of the engine, unlike the previous method. But if that's the case, why don't automakers make this improvement themselves, since increasing the compression ratio to the maximum can be achieved at the design stage? It turns out that there are limitations due to the need to adhere to certain standards. In this case, we are talking about gasoline. Increasing the compression ratio is associated with harmful detonation processes, but there is a direct correlation. To avoid negative consequences, you just need to use fuel with a higher octane number. Automakers cannot take such a step because it is associated with the high cost of premium gasoline brands. For the average motorist, this option is obviously unacceptable. However, for those who want to achieve an increase in power, regardless of the associated cost increases, this method does not look so bad. The fact is that switching to higher octane fuel, even without increasing compression ratio, guarantees efficiency gains in the form of lower gasoline consumption, so the increase in price will be largely offset by the increase in fuel economy. There are two ways in which an engine can be boosted by increasing the compression ratio in the cylinders. The first involves installing a thinner gasket between the BC and the cylinder head. However, there is a possibility that the valve may collide with the piston due to the change in the piston stroke distance, which is fraught with great trouble. So, in practice, thin gaskets are rarely used, and if they are carefully calculated. The situation can be remedied by installing modernized pistons, which have a deeper notch. Such improvement will cost you more, and you will have to adjust the timing due to changes in the timing parameters. The second method requires boring of the cylinders and, accordingly, the use of pistons with a larger diameter. Although this option can be attributed to boosting by increasing the volume of the engine, the compression ratio will also increase. Because the volume of the combustion chamber itself remains unchanged, and the changes affect only the volume of the cylinder. If the ratio of these two volumes changes, the compression ratio will also increase. But here we must take into account another nuance. With standard powertrain settings, the lower the compression ratio, the more power gain can be achieved by increasing compression in this way. Read also, what is a snorkel and how it is mounted in the car. Reducing mechanical losses. Ideal eternal engines do not exist. This truth we learn with mother's milk, from school. The internal combustion engine is not the most efficient type of motor in this respect. Its average efficiency does not exceed 30%. And it is quite obvious that the ceiling here is not much higher. If we leave aside fuel losses due to the rapidity of ignition and combustion cycles, about 30% of fuel is lost for this reason. We can only rely on the reduction of mechanical losses. Their sources are known. Pumping losses, friction in the gearbox, losses during operation of numerous auxiliary equipment. The main problem is considered to be the friction of the pistons against the cylinder walls. Here we have both a large contact area and high forward speed. How can losses be reduced? Here, too, there are several options. Use of prefabricated oil rings, constructive increase of the working clearance between the rubbing parts, the use of connecting rods of lower weight. All three methods are realizable, but they require careful balancing and weighting procedure, i.e., selection of all CMM parts by weight indices. If we talk about pumping losses, the main share of the power unit efficiency reduction is due to friction in the crankshaft journals. It is possible to reduce losses by installing a camshaft characterized by wider operating phases. If this is supplemented by the use of a system called dry crankcase, it is possible to achieve a significant reduction in pumping losses in the crankshaft area. Engine oil, strangely enough, prevents overheating by slowing down the rotation of the crankshaft. Finally, a significant portion of the power loss is due to the operation of additional equipment. The air conditioner, one of the most expensive consumers, pump, generator, and power steering are all driven by the crankshaft drive belt. But since it is impossible to refuse their use, the problem can be solved, at least partially, by increasing the pump and generator ratio, which, of course, will affect their characteristics, and not for the better. Optimization of the combustion process of fuel assembly, strange as it may seem, but to use this method, you can do without a detailed study of the theory that explains the features of the combustion process of the mixture in the combustion chamber. It is enough to understand that the volume of the CW must be minimized, which will avoid the occurrence of excessive heat losses and reduce the probability of detonation processes that have a huge impact on the combustion process of the fuel assembly. Significant improvement can also be achieved through more efficient mixture preparation. Reducing the combustion chamber and cleaning it more thoroughly are feasible measures aimed at optimizing the process of ignition and combustion of the mixture. Increasing the filling capacity of the combustion chamber can be achieved by reducing the aerodynamic resistance to airflow in the inlet and exhaust gases in the exhaust ducts of the engine. Another area of work is to reduce the aerodynamic resistance in the GB channels. The design of the exhaust system, especially the resonator, is also subject to optimization. Its shape and location are important, and it helps to achieve the desired installation of a multi-throttle system, involving the installation of exhaust pipes with individual connection to the cylinders. Once again, about the resource of boosted engines. This question must be chewed up because many car owners are convinced that forcing a procedure exclusively one-sided, leading to a decrease in the resource of the motor and its systems. Everything is not so unambiguous here. There are plenty of factors influencing the engine life: the level of boosting of the power unit, the degree of load increase, operating conditions, and such a subjective factor as the quality of technical fluids, fuel and oil, used. If we talk about the modes of operation of the engine at maximum loads, they are short-lived, regardless of whether the motor is forced or not. This allows to assert that engine tuning has no noticeable influence on its total resource. Moreover, if the forcing was performed qualitatively, the motor will work properly even more than without tuning. The fact is that the finishing of the power unit is always a well-thought-out individual work, performed with the use of the most accurate methods of weighting, fitting parts, balancing the engine. The more experienced the team of specialists, the more knowledge of such subtleties in the work of the internal combustion engine, which are often unknown even to car manufacturers, and this is not a bare assertion. In any case, the quality of work during boosting cannot be compared with conveyor assembly. The standards there are quite different. It is clear that such a qualified power tuning is a costly pleasure because, in addition to the measures associated with improving the motor performance, you have to work on adjusting the design of suspension, gearbox, brakes. We have already said that almost any motor can be forced, but the methods used for cars of different classes may differ significantly. Thus, to increase the power of a small-capacity internal combustion engine with a volume of less than 1,500 cubic meters, it will be necessary to crank the engine to prohibitive values, about 6,000 to 9,000 revolutions. However, there are many other ways to solve the problem. For example, you can install a 1.6-liter motor on a small car, but use a camshaft from a weaker engine, which has a smaller valve lift. Such a redesign will require adjustment of the camshaft gear with an advance of 3 to 4 degrees. Such a power unit will have good dynamics already from the lower RPM. If you take the VAZ motor 1.7 liters, which has a piston stroke of 82.40 millimeters, and the crankshaft 78.00 millimeters, then you can try to install a camshaft with a valve stroke of 10.92 millimeters. Such a boost is considered very promising, because the tuned motor has a decent torque in almost the entire speed range, while being able to spin up to 8,000 RPM. Other approaches should be used for medium power engines. For example, a 1.8-liter engine can also be boosted so successfully that the driver can shift into high gears at relatively low engine speeds. For this purpose, it is enough to install a camshaft with a valve lift of more than 12 millimeters on such a motor. You will have to pay for it with idle speed, which will become unstable, but not critically. And the most stable will be the mode at 1,000 to 1,100 revolutions. But it should be recognized that such tuning will lead to reduction of motor resource, and you should be especially careful at maximum revolutions. The load will be so high that the crankshaft may crack. Such cases are known. It is believed that the decisive role in the finalization of the motor is played by changes made in the design of the cylinder head. If everything is done correctly and carefully, you can count on a power gain of 20%, and if combined with other methods, the whole 30%. This is achieved thanks to a number of improvements: better fuel mixture preparation, better filling of the combustion chamber with mixture, optimization of the combustion process itself, and reduction of losses in the exhaust duct. The same purpose is served by installing a zero-resistance filter, and also at the expense of reducing the engine life, using a spider exhaust manifold with multiple outlets, straight-through muffler. True, these improvements provide an insignificant increase in power, but their accumulating effect should not be ignored. Note that tuning of the exhaust/intake tract noticeably increases the cost of the procedure of forcing the engine, not corresponding to the final result, but it is a matter of taste, desire, and opportunities. Thus, engine boosting is a very resource-intensive and expensive process, but if it is done by professionals, the result will be quite satisfactory. But do not forget that other systems are also subject to changes, which entails appropriate adjustments in their operation, maintenance, and repair. In conclusion, the theory and practice of engine boosting reveal a fascinating intersection of engineering and performance enhancement. By understanding the principles behind forced induction and its practical applications, we can appreciate how these technologies significantly improve engine efficiency and power output. As we continue to innovate and refine these methods, the future of engine boosting promises even greater advancements, paving the way for more powerful and efficient vehicles. Thank you for joining us on this journey into the world of engine boosting.